Dr. YASHOVARDHAN SIWACH, presenting a video on virtual reality assisted teaching of ophthalmology in MBBS.
Good afternoon, sir. Thank you for giving me this opportunity. I would like you to watch my video. Can you arrange the volume?
Now, what if I were to tell you that you need not be an astronaut to explore the fascinating realms of space anymore? What if I tell you need not shell out thousands of rupees for experiencing the beauty of that very place which has always been on your travel bucket list? What if you could observe the wild up so close? If all of this sounds exciting to you, then let me introduce you to the fascinating world of virtual reality and its possible applications in medicine over the next few minutes. Virtual reality is a simulated 3D environment that enables users to explore and interact with the virtual surrounding in a way that approximates reality. Virtual reality has found its applications in many fields, including but not limited to war zone simulation for army training, architecture and civil designing, video games and entertainment, medicine and surgical training. So how does one enter the 3D virtual world? Well, all you need to do is wear a VR headset which covers your eyes all around and displays the same image but from a different perspective in both our eyes. When our binocularity kicks in, we get to sense the depth of this virtual world. Just like how in this video the roller coaster is shown in each eye, but with a different perspective of the same video is displayed, and that's what helps in creating a three-dimensional video. These headsets also do have a built-in gyroscope which senses the movement of your head. We all have had lectures in our colleges till now, and there is no denying the fact that our professors have always had this magical aura surrounding them, which makes the toughest topics seem easy after the lectures. But now in 2022, we definitely can, and so we should, take the aid of technology for the same. The traditional methods of teaching rely a lot on imagination, as well as how well a person can understand the drawings and the diagrams, which are often used to explain the anatomy, be it at a macro or a micro level. But if we were to add the third dimension and a lot more to our teaching and learning method, the end result? It would be a multi-sensory stimulation and experience which would be way more beneficial than the current methodology. Virtual reality thus allows a multi-sensory interaction with the virtual environment, thereby making it an ideally suitable tool for effective learning and understanding of the intricate details of ocular anatomy. So with this idea in our mind, we started on a journey of creating a three-dimensional virtual reality-based anatomical model of the eye. The 3D model of the eye was made using a CAD software called Autodesk Inventor, wherein initially all the individual parts were designed and then later on they were assembled together into one form. Rendering of the same was done using a software called Blender, which gave the eye model a very realistic appearance. Finally, Unity was used in order to make our model compatible with the virtual reality world. Our primary aim was to make the model as anatomically correct as possible while making it appear very realistic. Not only this, but color coding was such that the model could be relatable to the images seen in textbooks, and thus that correlation was ensured. Finer details like placement of the trabecular meshwork, the Schlemm canal, extraocular muscle insertion, etc. were also given due importance. Then it was time to introduce the students to this virtual world. After a brief class on the topic for the day, the instructor wore the VR headset and took the students for a tour around the eye, explaining the importance of all the structures and relevant clinical aspects. The students were able to see what the instructor was experiencing on a display screen. Later, the students also got hands-on experience with the VR headset and were able to navigate their way around the eye. Relevant clinical aspects like various mechanisms for open and close angle glaucoma, for example, were displayed just beside the 3D model of the eye as seen here in the window, which gave a very good comparison of anatomy in health versus pathology in real time to the learners. Potential uses in the foreseeable future include the use of haptics to create surgical models of the eye on which training the residents will translate into a better understanding of the surgical technique. Haptics offer an entire dimension to a virtual reality or 3D, and it basically provides a way to translate our movements in the physical space into our movements in the virtual space, thus developing skills like that required for a continuous curvilinear capsulorhexis, for example, and can be initially learned over the 3D model before providing to do the same on a patient. With the availability of VR headset at a price starting from 500 to 800 rupees, the future definitely holds a space for the various applications of VR, and the possibilities of the same are endless. In the end, I would like to quote what Morpheus said over 18 years ago in The Matrix. Have you ever had a dream that you were so sure was real? What if you were unable to wake from that dream? How would you know the difference between the dream world and the real world?
Thank you for your attention, sir.
Yashovardhan, we are all very keen to know how you developed it. It was a development that was done with your ophthalmology department with the team
Center, yeah.
who
Yes,
worked
sir.
on the logistics as well as on the technicalities. And at which stage of the anatomy are you? Because after the anatomy will come the diseases,
Yes.
and after
Yes,
the
sir. Yes, sir.
diseases will come also the process of the surgical process, the management processes.
Yes, sir.
So,
Basically, this was the brainchild of my professor and HOD, Dr. Gopal sir. I'm from Amrita Hospital, Kochi, and in our hospital, apart from our department, there is a separate 3D lab, which is the initial in the video. Initially, there was some sort of a heart that was being pulled out from the chest, is what is already being followed in pediatric cardiology department, because various complicated cases, they want to see it before they proceed to surgery in real life. So with the help of that department, and of course guided by Gopal sir, and I and one more software engineer was there. I would be telling him about the details and how the anatomical structure should look like. Although this is the first time we all are trying for it, so certain things did not match our expectation, but we are still working on it. As of now, if you could see in that video, the retina part was not as developed, and I was initially focusing to get the anterior segment right as much as possible. And our future aim in this is to first complete the basic anatomy of the eye correctly as possible we can display. And the other thing is that we would want to, we ideally would want a scenario wherein a person can just walk into that eye, and they'll have some pointers there. For example, if they see some superficial hemorrhages and narrowing of arterioles, they can just click there, and that will tell you about the pathology. And the clinical picture, autofluorescence, fundus fluorescein angiography, OCT, relevant anatomy should be displayed just at a click. So that is what we want to develop first at our first phase, and the second phase would be to include the haptics along with this. And haptics, what extent to which haptics can help is that it won't replace surgeries definitely, but things like a continuous curvilinear capsulorhexis, which requires sort of feedback also, that can be given easily. And that has been done other places also. This is just an indigenous thing that we are trying to do.
What about the validation? So how you are validating these things?
So
Anatomical-
regarding validations, the thing is, regarding sir, MBBS teaching validation, are you asking
Yeah,
about all
yeah.
the software? Because once a part of the eye is developed completely, like let's say anterior segment is completed, then we plan to conduct an MCQ based exam. MCQ based exam on people who have been taught the same topic using presentations and in classes. In the same batch, batch would be 50-50, like 50 people will be teaching through the traditional method versus 50 people who had access to this too. It's like an additional. We cannot, as I stated in my video also, we cannot
So
replace
is it
traditional.
randomized or?
That we'll be planning on, sir. Yeah, that study is pending and we have to do. Actually, I'm in my final year and there were many other things that were going on.
It's under patent?
Yeah. Sorry, sir?
Is it under patent?
No. As of now, no, because it's not complete yet. Once it is complete and we can publish some paper about it, that will be very great.
Okay, thank you.
Very innovative. Kudos to all of you.
Thank you, sir.
The one difference I think that in your second stage, what you all are planning is to, the haptics. With regards to the haptics, you already have some very nice
Yes.
models that are
Yes,
available. They're not that expensive. They can be used multiple times for doing CCCs, for doing phaco's,
Yes,
for
sir.
doing vitrectomies,
Yes,
for
sir.
doing ILM peels. So
Yes.
those are very much available, but probably this would have an advantage is if it can give you feedback as to where you're going wrong.
Yes, sir.
Then I think that would make a definite difference.
Yes,
for
sir.
sure.
Yes. Definitely. We'll try for the same.
Very good.
Thank you, sir. Thank you, sir.
So just on curiosity, how long is it going to take you to develop the
remaining, yeah.
aesthetic structural
Aesthetic part is
component of-
almost complete because initially what we were doing is to make the vein and artery like in an animated format. But now what we are doing is that we'll paste in images, real life patient images that will be superimposed in the retina, like maybe ultra wide field image that is superimposed inside. So wherever you look, it's like you're looking at the real retina inside. So that is our plan. So that has speeded up our process a bit.
So regarding the patient counseling, is it also in the pipeline?
Sorry, sir?
Patient counseling through this?
Patient counseling through this can be done, although it might be a bit time consuming, and as in the video, what I was experiencing was only experienced by the students after I showed them initially and then handed over the headset. So that is, it can be done successfully, definitely, especially in patients who are, want to really know what is going on with their, and not convinced, maybe. Not convinced with your paper drawings or model-based things. They can definitely see this, and if we include the videos of the surgeries that have been done already on similar case scenarios, for example, macular hole surgery, if they want to see a surgery going on in 3D also, that is also a good option.
Okay.
Thank you. Thank you, sir.